Before let's get into that, okay? Is data normally distributed? So recall, these are all still things that are true about a normal curve. 100% of data is underneath it. Graph is symmetric. The mean is at the center. Half of the values are below the mean, half above the mean. And this one here this is what we're going to check for. Does it follow that rule? It's called the empirical rule. Empirical rule, my bad. Another thing you will observe is that the mean, median, and mode, they're very close to each other when you have normally distributed data. Okay? So if you were to do a number line or anything like that, you would see that things are clustering up around the center. Okay? So here is an example here. We are not going to graph necessarily, but it could be involving a graph where you have data that it's not going to be perfect, right? But if you think about, if you were to combine these midlines, right? And you just connect the midlines and the resulting curve is there. This one does approximate a normal curve, right? Where you have most of your data around the center and then it tapers off towards either end. So this is normally distributed. Not perfect, but close. That's what I'm trying to say here, that we would consider that data probably, it would probably check all the boxes for being normally distributed. Look at the data to the right here. You've got, this is called a right skewed data, where it's skewed to the right. It's biased towards the right. Okay, not symmetrical, okay? Therefore, not normally distributed. So on a graph, it's actually fairly easy to see whether or not data is normally distributed, but it takes a long time. So we are going to check in a different way. Okay, we're not going to check using a graph. Okay, let's look at the steps, okay? Study sheet material. Steps to follow. Determine the mean and the standard deviation. Sort your data if possible. This is new. I've done this to make your lives a lot easier. So we're going to create a frequency line. Okay? And how are you going to make your frequency line? It's very, very easy. Okay? You basically start with a number line like this. We're going to put the mean at the center of that line. And I don't care. This is not drawn to scale. This is not drawn to scale. So you're going to almost do what we started to do with a normal distribution curve. You're going to add a standard deviation every time you go to the right. And you're going to subtract every time you go to the left. Okay? And so, by the way, these are all going to be numbers along the x-axis. They're all going to be numbers. You have essentially created bins. So once you've come up with the numbers, I'm going to ask you to make those lines a little longer. Okay. This is a bin, this is a bin, and so forth, right? These are all bins that you're going to fill in. And we're going to know, similar to a frequency table, we're going to fill these in with the number of data points that are between these two values, and then between these two values, and so forth. We're going to actually fill in these bins. That's step number 3. So create the frequency line, fill in the bins that you've created, and the last step right here, we're going to check if data follows the 68, 95, 99.7 rule. We're going to check if 68% is within 1 standard deviation, 95 within 2 standard deviations, and 99 within the first 3 standard deviations, or 3 standard deviations to the left and to the right. I need you to understand this. Within, the word within 1 standard deviation means, this is your average, it means if you go back 1 standard deviation or up 1 standard deviation, like the amount of values that are in here should be 68%. If you go 2 standard deviations, within means 2 to the right or 2 to the left. If you add up these 4 boxes, these bins, it should add up to 95% of your values that you've collected, okay, and so forth. And this is new. If data is off by more than 5%, we will conclude that it does not follow the rule. So we're not going to be bang on 68. Often we're going to be off by a little bit. If we're within 5%, you're still good to go. Okay? If it's more than 5% off, that's when we have a problem. Okay? So let's dive into our first example, and then I need you to be able to do this because this is going to be worth 3 to 4 marks depending on how much I ask. Okay? So this is the last step, checking. And if time allows today, we're going to add a study sheet entry. If not, we're going to do that tomorrow. So go to page 45 and please enter all of those values into your L1. Just enter it all into L1. Please do so because you want to follow along what I'm doing here. Okay. Still working on it. You want to check to make sure that your last number is 50, right? You have 50 values in here. So you count, right, 2, 4, 6, 8, 10 this way, and 5 this way. So 50 values. If you don't have 50 values, you want to double check. So it is very standard to figure out your mean, median, mode, and all of that. So let's go ahead and find that out. So for A, I'm going to go stat, calculate 1 variable stats. So there's my mean. 1 or 2. We've got minutes, right? Standard deviation is 24.73. Those are the, okay, I'm going to say this. Those, if I don't ask you for the other ones, this is where I would stop, okay? These are the ones that we absolutely need for what we're doing next. But I did ask you for the other one, so let's go ahead and find that. Median, just scroll down on your screen. It's 99 minutes. Everything is in minutes. Sorry, you can't see that. And mode. Mode, you gotta, what do we do for mode again? You sort, okay? You sort your list, you go to your list, and then you look it up. I've got 89 shows up 1, 2, 3, 4 times. '96 shows up 3 times, so 96 is not it. 99 shows up 4 times, so you've got 89 and 99 right now. You've got 4 100s. And everything else just 1 time or so. Okay, so the mode is 89, 99, and 100 minutes. So you gotta, like, if you have multiple modes, you have to separate them by a comma. You can put units next to every single one of those, but that's nonetheless how you would do that part. To be honest, on a test, I'll tell you straight up, I will not care about that. When it comes to this one, I want these two. Okay, those are the most important ones. Create a frequency table with a standard deviation as your interval width. And here's where I want you to change. I'm not going to ask you to make a frequency table. It's a frequency, what did I call it? Because I changed that not too long. Frequency line. Okay. A frequency line, change that. So you grab a ruler, or if you don't have a ruler, I don't care that much for this. This is a frequency line. Okay? We're going to make bins. That's basically what you want. You want to make bins. So make a line. We're going to, at the very center, you put your mean, which is 102.5. And then just make 3 bins towards the right. And you make 3 bins towards the left. That's where we're going to put our numbers in. And we're going to add a standard deviation every time we go to the right, which is 2473. If you have a highlighter, I'm just going to ask you to highlight your standard deviation and highlight the fact that that's what we're adding there. So make sure you use your calculators for this. You don't want to get this wrong. So it's 102.5 plus 2473. So this is 127.23, okay? Let's keep adding. So to this, we add 2473. That's 151.96. And one more time. That's 176.69. Go ahead. And then we subtract a standard deviation every time we go to the left. And you can, if you forgot, it's because we know that if we have 6 standard deviations, right, 3 to either side, that technically accounts for 99.7% of our data, right? So it's almost all of it if you have that. So I'm just going to give you the numbers here. This is 77.77. This is 53.04. And this is 3.58. Oh, sorry. 28.31. My bad. And make those bins a little taller. We have 50 values to put into these bins. Values, right? Which by now should be arranged. Make sure you copy to this point, because this is the part that students get wrong, like how to do this next part. These are bins, right? These are all bins that we're going to fit in, and this bin right here will have all the values between 2831 to 5304, right? These are what, movies in a movie collection. So the movies that lasted between these 2 times are going to go in here. And then we're going to the next and to the next and so forth. I'm going to move this off to the side and see if I can fit my calculator in. Okay, so I'm going to go to Stat Edit. Go to my list, which is already sorted. Let's see if I can zoom out a little bit. There we go. 25 doesn't even fit in here. You see that? No big deal. Put it outside. Like 25 goes out here. It's like less than 28.31, so no problem. Then the next value is 73. A 25-minute movie? That's a very short, that's an outlier, right? Anyways, 73. Where is 73? It's gonna fit in here, between 53 and 77. So watch what I do. I just go 73. The next one is 78. 78 has to jump into this box because it's bigger than 77.77. So 78, 81, 84, 86, 87. Okay, that's 5 values. Another 87, 88, 89, 89, another 89. So you've got 10 already. Another 89, 90, 90, 91, 91, 94, 94, 95, 96, 96, 96, 98, 99, 99, 99, 99, 100, 100, 100, 100, 101, I'm still in this bin. 101, 102, I'm still in this bin. 102, 103, now I gotta jump into this bin because it's bigger than 102.5, right? So 103, 105, 106, 110, 117, 122, 125, 129, I'm jumping in here. 135, I'm still here. 144, 154, I jump in here, goes into this bin. 155, 162, 180, it's outside here. Okay, 180 is outside, past 176. And that's it. So, you've now organized. What I do is I quickly add it up. Watch, there's 1 in here. There's another 1 in there, in this bin. This bin has 5, 10, 15, 20, 25, 30, 34 values. Okay, so 34 values in this bin. Over here you've got 7. And you've got 3, 3, and 1. Please do yourself a little favor. Check that you have 50. So 1 and 1, that's 2. That's 36. 36, that's 43. 46, 49, 50. So I checked. I have 50 values in. They're all in these bins, so we're good to go. We didn't miss a single one. And here's where you need to, you're not done yet. Okay? Now you need to check. Does it follow? Does data follow 68, 95, 99.7? That is the ultimate question here. So you're going to check plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. This is what you do. Every single one of these, you're going to figure out how many values are in 1 standard deviation compared to 50. 2 standard deviations, how many values are there compared to 50? 3 standard deviations, how many values are there compared to 50? Because 50 is your total. That's like all values under the curve. So now follow me, please. 50 is the total. 1 standard deviation, that means from here to here, right? Like 1 standard deviation is these 2 bins right here, so 34 and 7. 34 plus 7. I would do it like that if I were you. And I'm going to say this and this, okay? These are the two bins that you're adding here. So 34 and 7, that's 41 out of 50. Multiply that by 100 because we want percentage. So you're going to go 41 divided by 50, multiply that by 100. That's exactly 82%. Versus, we're expecting what, 68%? Like we would want, if this is normally distributed, then we are only expecting about 68% of values to be there in those two bins. But we've got way more, right? You see that? What's the difference here? Breaks the rule, right? Over 5% past the 68% limit, okay? Therefore, not normally distributed. You technically are done. You're allowed to stop here and say, hey, wait a minute, right at the beginning we're failing this test, the 6895. So, but not always will it fail. Okay, you got to keep checking. So let's keep checking. If you want plus or minus 2 standard deviations, it might get a little messy, so it's up to you how you want to highlight this. I'm going to use green because there's already orange in here. You want to go 2 standard deviations to here. So you basically want to go, if this is your mean, you want to go 2 standard deviations to the left and 2 standard deviations to the right. You want to like combine all 4 bins and compare them to 50. So this would be 1 plus 34, like if I start from the very left here, 1, 34, 7, 3. Or you just go 41 plus 4, right? So that's 45 compared to 50 times 100. That is 90% versus 95%. In this case, you actually passed the test. You're still within the 5% deviance, right? So you can be 5% off on the low end or on the high end. So this checks out. Passes the test, okay? Within 5%. You are within 5%. Let me bring this up a bit. And the last one is 3 standard deviations to either side. So watch this. You got to go all the way to the left here where you started and add up all the bins. So 3 and another 3. You're going to add up 6 bins together. If you think about it, you're adding up everything except for the 2 here at the end, right? That's 48. So it's 48 divided by 50 times 100. That's 96% versus 99.7. To be honest, this one almost always passes. This is not where the problem is going to be. Okay, passes, test. But that's it. Like, that's how you check whether or not data is normally distributed. Okay. But this is what I would want to see, like, does it or does it not pass at the end of the day? And this particular data set is not normally distributed, okay? So we'll just finish with that, okay? Data is not normally distributed. Since it does not follow the 68, 95, 99.7 rule. Boom, you're done. Okay. I'm going to ask you to give this a try. 1 second here. So you're going to try page 47. So I'm going to write the numbers here somewhere. Page 47. Give me 1 second. And page 48. No, I think 48 isn't quite. I meant to say 49. Okay. Page 47 and 49. One of these passes, one of these does not pass the test. Okay. So I want you to go through this. Before you go home, you should have completed at least one of these pages, okay? And I might actually take the time towards the end to add one more curveball that you will have encountered in your take-home quiz, okay? All right, let's be productive. Get your